Hey there, space explorers. Ready for another deep dive? You know we only pick the coolest stuff in astronomy and space exploration, right?
And this one, well, this one is a game changer. We're talking about the first planet ever confirmed, orbiting a star like our sun, but, outside of our solar system.
Yeah, it was 1995 and pretty much changed everything.
Like, whoa, hold on, there are other planets out there.
Yeah.
Really?
Astronomers had suspected it for sure, but had never found proof.
So this discovery was a big deal.
Huge.
So, okay, let's go back to 1995. Two astronomers, Michel Mayor and Didier Queloz, they're using this really advanced technique called radial velocity, and they're looking at this star called 51 Pegasi.
Right, and 51 Pegasi is a G-type star, pretty similar to our sun.
So same size and temperature?
Basically, yeah, same luminosity too.
Yeah.
It was a good place to search for planets because of the similarities.
So hold on, back up. What exactly is this radial velocity technique? How does it work?
Okay, so imagine a star and a planet, right? And they're, orbiting each other around their center of mass.
Okay.
The star is way bigger, obviously, has a lot more mass, so it doesn't move much. But that planet's gravity, well, tugs on the star just a little bit.
So the star's like, I'm huge. The planet is like, but I'm here.
Pretty much.
Yeah.
So the star wobbles a tiny bit. That's what radial velocity measures. It's picking up on that tiny wobble.
Ah, I see.
And as the star moves, wobbles towards us, its light gets kind of squished, so the light waves look bluer. And when it wobbles away, the light waves stretch out, look redder.
Oh, like the Doppler effect.
Yeah, exactly. Like when a siren goes by and the pitch changes.
Makes sense.
So by really carefully looking at the starlight, astronomers, they can see those tiny shifts in color, and that tells them how the star is moving.
And that movement can tell them if there's a planet there, even if we can't see the planet directly.
Exactly. So Mayor and Queloz, they were looking at the data from 51 Pegasi, and bam, they found this pattern, clear as day, in how the star's radial velocity was changing.
Wow.
And it was repeating, so it wasn't random. It was like a signal.
Screaming, planet.
Exactly. So what did they learn about this planet from, that signal? What was it telling them?
Well, first, the pattern was repeating super fast, like every 4.23 days.
Whoa, that's a short year.
Really short. That means this planet is zooming around its star, way closer than Mercury is to our sun.
So it's got to be hot there.
Super hot. And then how much the star's speed was changing, well, that told them about how big this planet was.
Okay.
And it turned out to be, get this, about half the mass of Jupiter.
Wait a minute. Half the size of Jupiter and whipping around its star in less than 4.5 days?
Yeah, like 7 times closer to its star than Mercury's is to the sun.
That's nuts. No one expected that, right?
No, not at all. It was a huge surprise because before this, everyone thought, planetary systems would look like ours. Small, rocky planets close to the star, gas giants way farther out.
So this was like, okay, maybe we don't know as much as we thought we did.
Right.
I bet other scientists were like, hold up, are you sure about this? Could be something else.
Oh, absolutely. They had to be really sure. They thought, what if it's not a planet? What if it's 2 stars, like a binary system, with one star much dimmer and smaller?
Yeah, that could make the star wobble too, right?
Yeah, but they figured out that whatever was causing the wobble was too small to be a star.
Ah, okay. What else?
They thought maybe it's star spots, like sunspots, making the star's light change as it rotates.
Yeah.
But when they looked closer, the pattern of the changes didn't match what star spots would do.
So that wasn't it either.
Nope. And then they thought, maybe the star is pulsating, expanding and contracting. That could change its radial velocity too.
Yeah, maybe.
But again, didn't fit what they were seeing. Pulsating stars have their own, signature, and 51 Pegasi wasn't doing that.
So they went through everything, tried to find another explanation, but nothing fit except
The giant plant.
in a crazy close orbit around a sun-like star.
Yep.
Mind blown.
I know.
Okay, so this discovery, it's huge, right? But how did other astronomers react? And what did this discovery mean for, our understanding of planets and solar systems?
It was a game changer, but we'll dive into all of that right after the break, so stay tuned.
Welcome back. So we were talking about 51 Pegasi b, this massive planet, hugging its star.
Yeah.
It kind of threw a wrench into what everyone thought they knew about planets and solar systems.
Yeah, big time. It made everyone rethink everything.
So let's talk about that. Before this discovery, most astronomers, they thought other planetary systems would be like ours. Rocky planets near the sun, gas giants farther out. Why did this discovery change everything?
Because of hot Jupiters. 51 Pegasi b, it's the first one we found, and it's like, how did a gas giant get so close to its star?
Yeah, like finding a walrus hanging out in a sauna.
Exactly. It just didn't make sense with the old ideas. That's where this idea of planetary migration comes in.
Planetary migration. What's that?
Okay, so picture a brand new solar system, right? A star is born, and there's this disk of gas and dust swirling around it. Planets are forming in the disk, and as they get bigger, they start messing with each other's gravity, you know?
Ah, so they're like pushing and shoving each other around?
Yeah, kind of. And all that gas and dust, that plays a part too.
Okay.
And sometimes all those interactions, they can make a giant planet like a Jupiter spiral in closer and closer to its star.
What?
Over millions of years, that planet ends up in a really tight, really hot orbit.
So hot Jupiters, they weren't born close to their stars. They moved there.
That's wild.
Yeah.
But hold on, if planets can move around like that, wouldn't that mess up the whole idea of a habitable zone? You know, where a planet could have liquid water and maybe life?
You got it.
Yeah.
Planetary migration, it throws a whole new level of complexity into figuring out where a planet formed and how it ended up where it is now.
So a planet could form far away from its star and then move into the habitable zone, or it could form in the habitable zone and then get kicked out.
Exactly.
Wow, that's crazy. It makes things way more complicated when you're searching for planets that could have life. You can think about like the whole history of the planet's orbit, not just where it is right now.
Mind-blowing. So back to 51 Pegasi b, this one discovery, it really did change how we study exoplanets, right?
Oh yeah, huge impact. First of all, it proved that planets exist around other stars. Before this, it was all just theory.
Like suspected but not proven.
Right.
But this discovery was like, okay, there are definitely other planets out there. We just got to find them.
Exactly. It kicked off this huge race to find more exoplanets.
I bet it also, like, pushed astronomers to come up with new ways to find those exoplanets.
For sure. Remember, 51 Pegasi b, they found it using radial velocity, but that's not the only way.
Oh, right. There's the transit method, where you look for a dip in the star's brightness when a planet passes in front of it.
Yep. And since 51 Pegasi b, there's been a ton of new tech developed, new telescopes built, like Kepler and TESS. These space telescopes have found thousands of exoplanets, all kinds of crazy systems we never even imagined. Yeah. It's like before, we were looking through a tiny peephole, and now we've got this huge window into the universe.
It's amazing to think about how far we've come since that first discovery. But even with all the new tech, there are still so many mysteries about how planets form, right?
Totally. Like those hot Jupiters, they're still a puzzle. We have some ideas, but we're still figuring out exactly how they end up where they do. And then there are these super weird systems we keep finding that just don't fit any of our models.
But it's still an exciting time to be an astronomer.
Absolutely. We're constantly learning new things and having to revise our ideas. It's a challenge, but that's what makes it so much fun.
You're right about that. So what's next for exoplanet research? What are the big questions astronomers are trying to answer now?
Well, the biggest one, I think, is, are we alone? We found all these exoplanets, many of them in the habitable zone, but we haven't found any proof of life yet.
Is there anyone else out there? That's the question everyone wants to know.
It's the ultimate mystery. And now we've got these amazing new tools, like the James Webb Space Telescope, that are going to help us look for signs of life in ways we never could before.
The James Webb, that's going to be huge. But how could it find signs of life on another planet, a planet that's light years away?
By looking at its atmosphere. A planet's atmosphere, it's kind of like a fingerprint. It has a specific mix of gases that tells you a lot about what's going on that planet.
Oh.
The James Webb, it's powerful enough to detect the types of gases in an exoplanet's atmosphere, like water vapor, methane, oxygen.
And some of those gases could be signs of life, right?
Right, like if you see oxygen and methane together, that's a pretty good sign that something's producing them, something biological. Of course, it's not going to be a simple answer.
Right, it's not like a big flashing sign that says, hey, life here.
Exactly. It's going to take a lot of careful analysis and ruling out other possibilities, but the James Webb, it gives us a real shot at figuring this out.
That's incredible. So James Webb, it's like the big hope for finding life on other planets.
It's definitely one of our best tools, but there are other missions too, like the Plato mission. It's launching soon, and it's going to focus on finding Earth-sized planets in the habitable zones of sun-like stars.
And we can't forget TESS. It's already up there, finding hundreds of new exoplanets all the time.
Yep. All these missions, they're working together to give us a much better understanding of what's out there.
It's amazing to think about how much we've learned since that first hot Jupiter was found.
No.
But even with all we've learned, there's still so much we don't know.
Oh, yeah, for sure. Like planet formation, that's still a big mystery. We have models, but then we find these weird systems that totally break the rules, and we have to start all over again.
Like those hot Jupiters,
Yeah.
right? They were a big surprise.
Exactly. That's what makes this field so exciting. There's always something new to discover, always something that challenges our assumptions.
You're right. It's like we're just scratching the surface of what's out there.
I think so. And it's not just about planets, you know? It's about understanding the universe, how we got here, where we fit in, are we unique, or is the universe teeming with life?
Those are big questions.
Huge questions.
Yeah.
And it's incredible that we're actually starting to get some answers.
Well said. I think we've given our listeners a lot to think about. Thanks for joining us for this deep dive into the world of exoplanets. It's been an amazing journey, and who knows what the future holds. Maybe we'll find life on another planet. Maybe we'll discover something even more incredible.
I can't wait to find out.
Me neither. Keep looking up, stay curious, and never stop exploring. Welcome back, space explorers. It's been quite a ride through the world of exoplanets, hasn't it? From that first surprise with 51 Pegasi b to this wild idea of planets moving around, migrating. It really makes you wonder what's next. What are astronomers, really focused on now?
I think the biggest question what everyone's asking is, are we alone? Like, we found all these planets, thousands of them, and many are in that habitable zone, but we haven't found proof of life yet.
It's a question as old as time, right? Are we the only ones?
Yeah. And to try and answer it, well, scientists have been working on some truly incredible tools, like the James Webb Space Telescope. It's going to launch soon, and, well, it's basically like the Hubble, but way more powerful.
Oh, wow. So what can the James Webb do that, other telescopes can't?
It can look at the atmospheres of exoplanets. Like, really look at them, see what gases are there.
Ah, so that's how we could find signs of life.
Yeah.
By looking at the air on another planet.
Exactly. A planet's atmosphere, it's unique, like a fingerprint. It tells us a lot about what's going on there. The James Webb can look for things like water vapor, methane, oxygen.
And some of those are signs of life, right? Like on Earth, we have oxygen because of plants and, all the living things.
Right. So if we find certain combinations of gases on another planet, especially oxygen with methane, well, that's a pretty strong hint that something is producing them, something alive.
Oh, wow. That's amazing.
It won't be easy, though. It's not just going to be like, oh, look, there's oxygen, must be life.
Right. It's going to take a lot more than that.
Yeah, it's going to be a lot of really careful analysis, ruling out other explanations. But the James Webb, it gives us a real chance to actually find out.
That's really exciting. So the James Webb, it's like our biggest hope for finding life on other planets.
It's definitely one of our most powerful tools. But there are other missions, too, like the Plato mission. It's going to launch in a few years, and it's specifically designed to find Earth-sized planets in the habitable zones of stars like our sun.
Oh, cool.
And we can't forget about TESS. It's already out there finding new planets all the time. Hundreds of them.
It's incredible how many planets we're finding. And it all started with that one discovery, 51 Pegasi b.
Yeah, it really opened our eyes to the possibilities.
But even with all the new planets and all the new telescopes, there are still so many things we don't know.
Oh, absolutely. Like, we're still figuring out how planets form in the first place.
Wow.
We have some ideas, some models, but then we find these crazy systems that don't fit at all, and we have to go back to the drawing board.
It must be frustrating, right? Like you think you've got it figured out, and then bam,
Yeah.
something new comes along and throws everything off.
It can be, but it's also what makes this field so exciting. There's always something new to discover, always another mystery to solve.
You're right about that.
Yeah.
I think we've given our listeners a lot to think about and a lot to look forward to. Who knows what we'll discover next?
It's an amazing time to be studying the universe. We're learning so much, so fast, and it feels like we're on the verge of some truly incredible breakthroughs.
Well said. And on that note, thanks for joining us for this deep dive into the world of exoplanets. Remember, keep looking up, stay curious, and never stop exploring.